necessary. Then I drag that down all the way through to her 62nd birthday. I also have the column of the years of cash flow. You don't need both, but sometimes if you're dealing with, the year 2013 and then 15 years from now, if you're assuming 2013 is today, equating that to time zero is sometimes helpful, especially if you're using the raising to the end value. So once I've got all those dragged down, these are the annual contributions increasing every year, and the last contribution, the 40th contribution at 62, is just shy of $7,000. Then I used my favorite NPV formula at 7%. That's that entire series except for year zero. You make a mistake with NPV, I just about guarantee you it'll be because you've included year zero and should not. Or forgot to add year zero if there wasn't. So that gave me negative $43,000. So stopping right there, what that means, if I put 43, or Amy puts $43,000 in her bank account today at age 22 and did nothing else, or made these contributions, the $2,200 plus 3% annually, those two values are equivalent. Okay? Once I had the net present value, I used my future value formula. 7%, 40 years, using that present value that I just calculated. It was already a negative value, so I didn't have to make it negative. These are my favorite kind of problems. They're my favorite for a reason. I've said this kind of stuff before. You cannot overstate the importance of planning early for your own retirement. You're all going on to engineering degrees, construction management degrees. You're all going to make pretty decent money. Retiring with $1 million is not out of reach. 3% of your salary is nothing. You wouldn't even miss that. She did 3%, and she's sitting at $650,000 at age 62. So, did anybody solve this the same way? You feel like you could solve this on the exam within 5 minutes?
Can you do it the other way, just to compare, like, if it's the same thing?
The other way, rather using net present value?
Like, each one, like the future value of each one, summation of that?
Yes. So what I would do then, to do it that way, I'm going to take this contribution.
Okay. And hold up, so she only gets paid on her 23rd birthday? What's going on right there? Why is she getting paid at the end of time period 0?
She's not getting paid at the end of time period.
She's not.
She did nothing at 22.
Okay.
It said in the problem statement that she's 22 now, and she's going to start contributing on her 23rd birthday.
Okay.
It doesn't specifically state today's her 22nd birthday.
Right.
You just kind of have to make that assumption. That she's going to start a year from now.
Okay.
Good? So I would take this payment here. I need to take that guy. And I would multiply it by 1.07. And I would raise that to, I'm going to go 40 minus that value. Have you all seen that? Yes, question?
Would you use as your PMT when you do the future value?
I can't hear you.
What do you use for PMT in that fee?
Nothing. There is no payment. What I did is I used the net present value to get all those values into a present value. That's my lump sum at time 0. So although I don't actually have 43,000, that whole stretch is equivalent to 43,000 up front.
Okay. Then what about your type?
You can always ignore type.
Okay.
You can ignore type and you can ignore guess if you're using IRR or rate. What type does, type changes where interest is calculated, at the beginning of the year or at the end of the year. But we don't want to open that can of worms again. All right, so what I'm doing here is I'm taking that value at year 1, and I need to move it 39 periods into the future. And the way I do mine, I could raise it to the 39th easily enough. But if I take the period, the end value, put it in parentheses, of the total time period, 40, minus the time period I'm at, via cell referencing, now I can drag that formula down. And what it will do is it'll take the next value, multiplied by 1.07, raised to 40 minus 2, then 40 minus 3, and so on and so forth. And I don't have to retype this formula every time. So each one of these should be the future value of those payments. And then the sum of that series should be the same as the sum that I calculated using NPV and future value. We agree? Good deal. All right, we got less than 5 minutes. I want to do 106. I'm not going to do this one. I mean, I'm going to do it. But I'm not going to do the answer today. This is for you guys. Oh, you can't see it. Thanks. So, 106. I love the practical stuff. This is my favorite.
I wonder why you chose that problem.
It's very near to my heart. And I love knowing this stuff when you're dealing with shady people. They go, "You, sir, are a shyster. I will not pay this rate." So you are free to solve it here in class today, and I will tell you you are right or wrong. Otherwise, for the next help session, next Friday, first thing we'll do is pick up with this one. I'm specifically going to answer that question. will say that both of you are thinking about this problem correctly. And I would say trust your instinct. If you have recreated request forms, I will accept them here now. Otherwise, I'll be in my office, 12 to 2.
So I calculated the future value of this.